to this tutorial where we're going to do some derivative practice for addition, subtraction, product rule, as well as quotient rule. So let's start. If you'd like, you could take a second to pause the video, try this for yourself. I will be going through them quite in detail. Okay, number 1. Y is equal to 4x cubed minus 5x plus 7. Well, we need to recognize here that we just have addition and subtraction coupled with power rules and constant multiple rules. So we're going to say y prime is simply going to be equal to the derivative of 4x cubed. Recall, we're going to take down the 3, 4 stays there, x, 3 to the minus 1, just 2, times derivative of x, which is just 1. So 3 times 4x squared minus, now the derivative of 5 times x, again, you could take down the exponent, which is 1 on the x, 5 times 1, which is just negative 5, and x prime, recall the derivative of just x prime is always just equal to 1 minus 5, and 7 is a constant, so it's just plus 0. Simplifying this is 12x squared minus 5. Okay, for the second one, again, bring down the exponent, we get 3 times 2, which is 6x, minus 5x, the derivative of 5x we just did also, which is negative 5, plus 10 is just 0, so we count that up. Okay, number 3, we have y prime is equal to, we're going to leave that 10 in front of it because we don't need to do anything with that. We have x squared, so we bring down the 2, x to the power of 2 minus 1, which is just 1, plus 5x to the power of 4. Again, we're going to leave the 5 alone, bring down the 4, x to the power of 4 minus 1 is 3. Okay, moving on, minus 2x, minus, and then we have 2 and x, bring down the exponent, which is just 2, derivative of x just 1, so it's just minus 2. And then the derivative of negative 2 is 0, so minus 0. Simplifying that down, we get 20x plus 20x cubed minus 2. Okay, next we're going to do the power rule. I'm going to do a little reminder here. The power rule, in my simplified way of learning it, is just going to be 1 times 2, means the derivative is 1 times 2 prime plus 2 times 1 prime, right? First thing times another is going to be that derivative. So we can use that method here, or you can use the actual rule for it. F prime of x, we're going to take x squared, leave that as is, take the derivative of 4x plus 1. 4x is just 4, 1 is 0, so times 4, plus 4x plus 1 multiplied by the derivative of x squared is 2x. Simplifying that, we have 4x squared plus 8x squared plus 2x. Furthermore, 12x squared plus 2x. Great. Number 5. Same method, same idea. We're going to take x plus 1, leave it as is, multiplied by the derivative of 3x squared, 6x, plus 3x squared, leaving it as is, multiplied by the derivative of x plus 1. Well, derivative of x plus 1 is just 1, because we have derivative of x is 1, plus derivative of 1 is 0, so 1. Simplifying that, we get 6x squared plus 6x plus 3x squared, or 9x squared plus 6x. Okay, number 6, move that down a little bit here, f prime of x. So this one looks a little more scary. Again, you could always just simplify it right away before you actually solve for the derivative. I always recommend that. Just to practice our power rule, we're going to leave that as is for now. Our product rule. So we get 12x, leaving it as is, multiplied by the derivative of x squared plus 2x. So x squared plus 2x, you could take the derivative of this on its own here, is 2x plus 2. 2x plus 2 plus, I'm running out of space. We were now at 12. The root of 12x is just 12 times x squared plus 2x. Let's simplify that. 24x squared plus 24x plus 12x squared plus 24x. Or 36x squared plus 48x. Okay? Quotient rule. So what if in each of these cases we had f at x is equal to x squared over 4x plus 1 instead of multiplying? Now there's two ways you could do this actually. I'm just going to show you first the quotient rule, and then another way you could look at it as, well, we have x squared, this is the same as just writing as, times 4x plus 1 to the negative 1, which incorporates product rule and power rule, right? We have a power and a multiplication. But I'm going to do it using the quotient rule. Again, to remind you, if we have 1 divided by 2, that's going to be 2 times the derivative of 1 minus 1 times the derivative of 2 over 2 squared, right? Top and bottom. So let's solve this one. F at x prime is going to equal to the bottom, 4x plus 1, times the derivative of the top, which is 2x, minus the top, x squared, times the derivative of the bottom, which is 4x plus 1, just 4, all over 4x plus 1 squared. Okay? Another example we could do is if we have f at x is equal to 5 over x cubed plus 2x. The derivative of that is going to be the bottom, x cubed plus 2x, times the derivative of the top, which is a constant, therefore it's 0, minus 5, the top, multiplied by the derivative of the bottom, which is 3x squared, plus 2. And all of this is all over x cubed plus 2x to the power of 2. And you could simplify this down. You could see that this cancels out, right? Just 0 times anything is 0, and so on. So this is the practice that we just did. Great. I'll see you in the next one.